Hi everyone, welcome back. So, no picture this time, but hopefully you can draw it if you want to. What we have is a 6061 T6 aluminum tube with a modulus elasticity of 10,000 KSI and Poisson's ratio of 0.33. You're like, what? Yes, it gave us Poisson's ratio this time. Now it has an outside diameter of 4 inches and a wall thickness of 0.065 inches. So from this, you should be able to guess that, yes, this is a hollow tube. Now what do they want to find? Well, they want to find the tension force that has to be applied to the tube to cause its outside diameter to contract by 0.005 inches. And if the tube is 84 inches long, what is the overall elongation? So, this is a group problem. Grab your imaginary friend, grab your dog, grab your cat, grab a potted plant, whatever you need to, and start working. Come back in a few minutes and then let me know how it went. So, 3, 2, 1, and you're back. So, let's try it out, see how it goes. Now, we're given a diameter contraction, so we can figure out what the strain we're going to need is going to be from that. And that would be a lateral strain of 0.005 inches over 4 inches. It does not matter that it is hollow. We just go from how much did the diameter change. So that gives us a strain of negative 0.001250 inches. Now we know what Poisson's ratio is. It was given to us with 0.33. And so from that we can then calculate our longitudinal strain. And maybe you start to see where I'm going here. We go from the lateral strain to the longitudinal strain, and through Hooke's law we can figure out the stress. And then from the stress we can figure out the load. So one step at a time, we're just connecting all these equations that we've been given one to the other. So it comes out that the longitudinal strain will be 0.003788 inch per inch. And now we're going to use that strain and Hooke's law to calculate our stress. We have a modulus elasticity of 10,000 KSI and the strain of 0.003788 inch per inch, which comes out to be 37.87 KSI. So that went pretty easily. Now we're going to have to figure out the area of the tube to understand the tension force. We know what the outside diameter is, and the wall thickness was given to us as 0.065 inches. Therefore, the inside diameter of the tube is going to be 3.870 inches. And so we can just get the area by taking the area of the outside circle and subtracting off the area of the inside circle for 0.803541 inches squared. Like I said, when you finish the problem, 3 or 4 sig figs, when you're doing the problem in between, all your in-between steps, give as many decimal places as you want, simply because you're going to mess up your answers if you start rounding that much. Rounding errors are a big issue. So with that, we get the force that's applied to the tube, which, stress is equal to force over area. So if I'm solving for force, I multiply both sides by area. And I'm given that area times stress is equal to the force. Now, we already know the longitudinal strain, and so since it gave us what the original length was, it's very simple to calculate the change in length, which would simply be our longitudinal strain times the length. So 0.003788 times 84 is 0.318 inches. Be very careful with how you plug this in your calculator. Be very careful that you don't confuse yourself with microstrains or another type of strain. When you're multiplying things out and calculating these questions, you need to make sure that everything's just in regular old strains. Microstrains is just to make the numbers look nice in the end. So that will be it. Thank you all so very much for listening, and I'll see you all next time. Have a wonderful day.